Hello everyone. So today we are going to solve this problem, house robber. This is LeetCode medium. So let's solve this. So it's given that you are a professional robber, okay? So I'm a professional robber, okay? So each house has a certain amount of money stashed. The only constant stopping you from robbing each of them is that adjacent houses have security system connected, and it will automatically contact the police if two adjacent houses were broken into the same night. Okay, so the basic funda is I have to robber rob the house, but I cannot rob the adjacent houses, right? For example, here if I rob house number 1, then I cannot rob house number 2. I can only rob house number 3 or house number 1, right? So let's take some examples here. Suppose this is our houses. Actually these values are money inside those houses, right? So what if I start robbing from here? So let's take the case 1 is I rob from this house number 1, the first house. Then I cannot rob this second number house. Then I can only rob third or the fourth number house. So let's say I've taken the third. So so this is the maximum amount of money I can get, and let's take another case. If I skip this and if I rob this second number of house, so it will be 2 plus I cannot take 3 and I can only have a chance of taking 1, right? 1. So this will be 3. So you're thinking that, okay, so either we will take the odd number or the even number, but this is not the case. This is not the case. How? Suppose we have houses like this: 2 1 1 3. So you'll think that, okay, let's take the odd number of houses, first even number of houses. Suppose this is 0th position, I have taken this, then the second position. So it will be 2 plus 1 equal to 3, or if I have taken the 1th position and the third index position, so it will be 1 plus 3 equal to 4. But this answer is not true. What we can do is, instead we can take this first indexed element on the 0th index element, that is 2, and we can take this last element index, that is 3, right? So the maximum amount of money we can gather here is 5. So yeah, there may be this is a little bit trickier. So let's solve this problem. We can easily solve this problem with the help of recursion. So recursion is like very simple. Solution from recursion is very easy. What we have to do is, let's start. Okay, where is my hero? Okay, all right. So I have already made this recursion tree. This took me a lot of effort. All right. So let's say we have this 1 5 1 2 3, this as an example, right? So what we will do is, either we will take this element 1, or we will leave this element 1, right? Either we will take element 5 or we will leave this element 5. So in this way we have to break this this array, right, into two subsequent value, right? So if we take this one element, then we have to make the jump of 2, right? For example, if I just let's make a copy here. So we have here, okay, let's do one thing. Okay, all right. So here we have 1 5 sorry, 5, 1, 2 and 3. Alright, so okay, if I am taking this element number 1, right, then I can only take this element, this position, or this, right? I cannot take this. So after this onwards I can take, right? I can take this, or I can take, sorry, or I can take this. So at any position, right, at any position, if I'm taking the this element, then I cannot uh, take the adjacent element, right? I cannot take the adjacent element. I have to take the jump of 2. If I'm taking the 5, then I have to take the jump of 2, right? And if I'm not taking 5, then like if I'm not taking this fifth element, then I have to only make the jump of 1, right? So I hope you understood this. So see, initially we have 1 5 1 2 3. So if we have taken the current value, that is 1, right, that is 1, so we will jump to 1 2 3, means up to this 0 1 2, the second index position, and we have to skip this fifth element. So it will be 1 plus and whatever return value we have. Okay, now here see, we have 1 2 3, and if we have taken again the current value 1, so we have to take the jump of 2, right? So if we have taken 1 again, then we have to take the jump of 2, so it will come to 3. So I'll explain you what is this. The green shows the element left for traversal, the yellow shows the index position. So we are at 0th position here, I is 0, and we have taken the jump of 2, so we are at currently 2nd index, and then again we have taken the jump of 2, then we are at 4th position, right? 4th position means last index, means this 3. I hope you are understanding this. Now the base, there is a base condition, right? We cannot go beyond this 4, then we have to return 0, right? This will return nothing. So recursive base case we have formed, that is if I or index is greater than equal to n, then we have to return 0. Alright, this is our base condition. And as I told you, this is one condition, that if we are taken a value, then we have to make the jump of 2, right? So suppose, and one condition is if like let's take on the value, taken current value, then we have to make the jump of 2. So taken current value means let's take the current value, that is nums of I. Let's extend this, nums of current index plus make the jump of 2, so that will be index plus 2, and okay. Alright, and if we have not taken, then what will happen? Suppose here I have taken 1, right? And if I have not taken, then I'll make the jump of 1. So if I have not taken this one now, then I'll make the jump of this here. I'll make the jump of 1 here. So we have elements 5 1 2 3, and we the current index position is 1, right? So let's traverse this. So again I have taken the fifth element, right, fifth element from here. So this will be then we have to make the jump of 2. So basically what will happen is we have to take the maximum of taken and not taken value, right? So maximum of 5 plus this returned value or not taken return value. I hope you are understanding this. 5 we have taken, and uh, something will be returned from here, right? Something will be returned from here to here. Let's see what will be returned. And so 5 we have taken, then we have make the jump of uh, 2, then it will come to 2 3, then again we have taken the current value 2 and make the jump of 2, that will be out of bound. So this is the third index, and if we make the jump of 2, then it will go beyond 4, that is 5. So we have to return 0 from here, and the value here will be max of, it will return the max of 2. 2 is taken and not taken value. Not taken is 3 left only, and here it will return 0, from here it will return 0, max of max of, okay, so here max of 0 and 3 plus 0, that will be 3, right? So it will return 3. It will return 3. It will return 3. So max of 2 and 3 will be 3. So it will return 3. It will return 3. So here we have returned value as 3. Return value as 3, right? And we have to find not taken return value now. So we come here. Let's move out here, and we have 1 2 3 left, and we are at index 2th position. Now let's take 1 here. So here it will be max of 1 plus taken value. Okay, let's make it a little big. Taken value or not taken value, right? Okay, fine. So if we have taken, then we directly jump to 3. All right, we directly jump to 3, means the fourth index. So from here it will return 0, from here it will return 0. So yellow means this is the base condition hitting. So I have worked hard for making all these things. So yellow shows it is the base condition hitted. So it will return 0, and it will be here max of 0 and 3 plus 0. So that will be 3. So the taken value here means, sorry, this will be return value, return value. So return value here is 3. So 1 plus 3, max of 1 plus 3 and not taken value. So let's go to here, not taken value. So we are at 2 and 3, right? Third index. So here our answer will be max of 2 plus return value or not taken value. So here return value will be 0 because we are at third index here right now, right? We are at third index here. See, I'll keep this thing with me. see, we are at here third index right now, right? So after the two step jump, it will get out of the bound from 4. It will get to 5th position, so it will return 0, right? So return value will be 0 here, 0. And not taken value, it will make the jump of 1, not taken plus 1. So we are here at 4th index. So after that, if it will make the jump of 2 or make the jump of 1, it will return 0 because it will get out of bound. So here we will have max of 0 or 3 plus 0. So here, from here we will return 3. Okay, from here we will return 3, right? We will return 3. So not taken value will return here 3. So max of 2 and 3 will be 3. Alright, so here, from here it will return 3. It will return 3 to this, and from here not taken value will become 3. So max of this 1 plus 3, 4, and 3 will be 4. So it will return 4 to this, and not taken value is our 4. So max of 8 and 4 will be 8. So finally it will return 8 to this, right? Max of 8, and here we will have, okay, what was our value here? 3 is 3. Okay, so here we'll have 1 plus 3. Alright, 1 plus 3, it will return 4. So max of 8 and 4. Finally we will return 8 here. It will be our answer. Alright, so I hope you understood this recursion. I tried to explain it from this diagram. I don't know whether you get confused or what, but yeah, so yeah, let's code this solution. Let's code this recursion, right? So what we did, just we have base condition here, and if we are taken the value, then we have to just make the jump of 2, and if we are not taken the value, so not taken current value, then we cannot add the current value, just will just jump for 1, right? And finally we have to just return maximum of taken current value and not taken current value, right? So this will be our answer. That's it, guys, that's it. This is our answer. Let's submit this. Okay, I'll make another function and solve. Okay, let's see what parameters we can pass later. Okay. Okay. solution correct. Okay, if index greater than n, then return 0. So the parameters will be int index, int n, and the array. So we have here vector int nums. Alright, and inside this solve function will pass n and nums. Same for here, n and nums. Okay, so recursion will work for only smaller number. We have to optimize it, and we have to just convert, make this we can optimize it with the help of dp, right? So will return solve. Initially we are passing 0th index and nums dot size and nums itself. Alright, I think this is good. Okay, to just define its data type. Okay, alright, so this is accepted, but this will not run for the bigger number, I guess, because this is recursion and it will recursively call, exhaustively call the already called value. Let's try to submit it. Most probably it will get TLE. See, we have time limit exceeded. So what we can do is we just optimize this solution. So I'll create a dynamic a DP array. So what could be the size of this DP? So we have here nums of 400. So let's suppose we have taken 401 or 402, say 402. Then here let's take the size and size of nums equal to nums dot size. Okay, for int I equal to 0, I less than of nums sorry, size of nums and I plus plus. Initialize dp array with -1 and the standard dp solution. If we have already like if dp of our index is not equal to -1, then we just need to return dp of index, right? And here return dp of index equal to max of taken current value and not taken current value. All right, so I think this should work. Let's submit this. Alright, so our solution worked, guys. Thank you so much. Hope you liked it solution. And just this is like the beginning of my explanation, so I might be confusing or whatever. Whatever suggestion you'd like to give me, please. I'm like I will accept heartfully those suggestions. And if you want to criticize, please criticize me for the explanation, and what I can improve, please tell. Thank you so much, everyone.